for this particular assignment, we need to know a couple of things. So vertical angles, I'm going to write some notes over here. Vertical angles. That's just when two lines crisscross like this. And anytime two lines cross, we can go across the vertex like this, so they're kind of opposite each other. And those two angles are congruent. And I can do a better congruent sign than that, I think. Congruent. There we go. So those are vertical angles. We also have a situation where sometimes we have two lines, and right now they're not parallel, but usually we have these guys parallel, but we'll go with it not being parallel for now. And we have a transversal. So this is called a transversal. And the other two are just kind of, for now, they're just lines. When we move a little bit more forward here, they'll be parallel lines. But for right now, they're just two lines that we're crossing. And we have some angle relationships here. So if they're in the same position, same relative position, so in this case, they're both above the red line, and I'm saying above kind of loosely there. They're both to the left of the pink line, so they're both in the same relative position. We call that corresponding. Corresponding angles. And then if we have, let's see, I'll go with green. So if we go in between the angles like this, so I have, this is below the red line and to the right, then I want to go to the other side and go down, and I want to be on, still in between the red lines. So now I want to be above, and I want to be on the other side of the pink line. We call these alternate interior angles. And alternate just means opposite sides of the transversal. Interior means they're in between the two other lines that we're talking about, usually parallel, but in this case they're not necessarily parallel. We're just looking at the naming. And then of course angles just refers to the fact that they're angles. Let's see, we'll go with orange, I guess. We also have alternate exterior. So now it's on the left, it's above the line. We want to go to the other side, we want to go to the right and slide all the way down. Now it's to the left of the line and it's below. So it's kind of opposites on these ones. So we can think of alternate also as opposites in both senses. So it's opposite sides of the transversal, and it's one's above the line, one's below the other line. Alternate exterior angles. And these are not the only examples. This is just a couple of each that I'm throwing out here. And then we also have a linear pair. So linear pair has to do with when they're on a line. So like this blue one and this orange one here would be a linear pair because they make a line together. So just some new definitions that we definitely need to practice here. So with this guy, what we want to do is take a look at what are we given. So in the figure below, we have angle 2 is 81 degrees. Let's see. Angle 2 is 81 degrees. And then they want us to go through and find the measures of the other angles. So if I'm looking at this one, I can use this vertical line, or this vertical angles, and I can go across. So this guy is also going to be 81 degrees. So I know angle 4 is 81 degrees. And then I can use a linear pair here, and I can, it doesn't really matter which one I do, but I can say these guys have to add up to 180 degrees. And I'm already using 81 of those, so I'm going to subtract, and that would give me 99. So this guy has to be 99 degrees. And then I can do that same idea with the vertical angles and go across and say that, well, this one also has to be 99 degrees. So we can kind of go around with one angle, we can go around and find all 4 angles there, just by using those two ideas, vertical angles and linear pair. All right, so I'm going to go ahead and I'm going to erase this so that I have a little bit more room here. So I have something along those lines. I know that's not perfect, but just so that I can redraw it real quick. 50, 11x plus 60, and they want to know what x and z equal. So not necessarily what the other two angles equal, but we do need the whole z. So when we go across here, these two both have an x in them. So that makes sense to set these guys equal to each other and their vertical angles. I could do a linear pair here, but then I'd have x and z. So first, I want to know what x equals. I'll go back and I'll plug it into one of these two just to figure out what the angle equals, and then we'll deal with z. So we have these two equal to each other because they're vertical angles. I know that the 11x plus 60 has to be the same thing as 3x plus 50. So now I can solve. So I'm going to start bringing the variables together. So that was a positive 3x. I'm going to subtract from both sides. So 11, let's see, what does that give us? 8. Yeah, I almost said nope, but that was true. It is 8. Plus 60. 3x minus 3x cancels and we get 50. I'm going to subtract 60 from both sides. 60 minus 60 cancels. I have 80. Let's see, that's going to give us a decimal. What did I mess up here? 8. Let's see, did I write it down all correctly? Oh, that should be a 13. That's why. 13. So this should be -2 instead of 8. So that's what I messed up. I was going to say, because we were going to end up with a decimal there, and that wouldn't have made a whole lot of sense. Because 50 minus 60 gives me -10. Now if I divide by 2, I get x equals -5. Not that it couldn't have been a decimal, but I know that Alex tends not to do that. So I could kind of see it happening, and I realized, oh, I must have left something off, and I did. I accidentally wrote 3 instead of 13. So it happens. You just go back and you fix it, and it's because I accidentally marked it here. I think I just didn't notice that there was a 1 there when I was regrabbing that. So now I know x equals 5. So I can go back to the equation and say if x equals 5, so this is going to be a 5, 11 times 5 is 55 plus 60. So 60 plus 55 is going to be 115. So this angle equals 115, but I don't want to know, that's not z. Remember, that's this angle here. It's 115. The entire thing is 180, and I'm using 115 of it. So I can use that linear pair, that line, to prove what z needs to be. So now I'm going to subtract, and let's see, I'm going to stack these guys just because I'm, let's see, that's 6, so 65. So z is going to be 65 degrees. All right.